Alright, so today I want to show you a couple examples of derivatives with exponentials. So in this course we're not going to look at anything other than exponentials with a base of e. That's going to simplify things greatly. But for today we're just going to go with the two examples I have here. So let's find the derivative of each of these two functions. Now hopefully you remember from class that the derivative of e to the x is e to the x, which is going to make things kind of easy. Just remember that this only works if it's e, and it only works if the variable is a single variable. There can't be any numbers, negatives, anything else there. All right? So what we're going to do is take the derivative. Now remember, when you have a plus or minus, you can take the derivative of these things individually. So the first thing I'm going to do is take the derivative of the first term. Now, since there's a constant in front, I can just leave the constant there, take the derivative of e to the x, which is e to the x. All right, then we're going to go plus. Now here it's going to get a little bit more difficult because this is not e to the x power. And so what I'm going to do is I'm going to say just for a minute that negative 3x equals u. So this is actually e to the u. Now I can take the derivative of e to the u because the derivative of e to the u is e to the u, right? Because the derivative of e to the x is e to the x. So if the x is u, then you take the derivative. Now this is a chain rule, right? Because I'm supposed to be taking the derivative with respect to x, but I just took the derivative with respect to u instead. And so if you remember, dy dx is equal to dy du times du dx. So I just took the derivative with respect to u. So now I need to take the derivative of u with respect to x. So I'm going to look at u, and du is negative 3. So I now need to write this as the derivative times negative 3. So now I need to put back in for u the original function. So I'll have f prime of x equals 2e to the x plus e to the negative 3x times the negative 3, so maybe I'll just go minus 3e to the negative 3x, and there's your derivative. Not too bad, huh? Got a little bit of chain rule in there. All right, so let's go ahead and look at the next example. So the next example is f of x equals x squared times e to the negative x. Now there's two ways you can do this. You can do this as a product rule if you want. Obviously this is the multiplication. Keep in mind that this is not e to the x, and so you will have to replace the negative x with a u and do the chain rule. Or I think the way I'm going to do it is I'm going to rewrite it as a quotient. Because if I take the negative exponent, move it down to the bottom, now I don't have to worry about the chain rule at all. Now all I have to do is use the quotient rule, which is when I have the quotient, which is u over v, it becomes vu prime minus uv prime all over v squared. So v would be the e to the x, so e to the x times u prime, which would be 2x, minus u, which was x squared, times v prime. So v is e to the x. You know, if you need to, you can write this out. X squared, v equals e to the x, u prime then equals 2x. Sorry, I should have done this first, but you know, just in case you need it. Remember, the derivative of e to the x is e to the x. We found that out in class last time. So u times v prime all over v squared. And v, of course, was e to the x, so that would be e to the x squared. Now, if you want to simplify this a little bit, you can make it f prime of x equals 2x minus x squared over e to the x. I just canceled out an e to the x. And you can leave it like that, or you can rewrite it if you want to a little bit further as 2x e to the negative x minus x squared e to the negative x, right? So I'm just moving that e to the x up on top and distributing it. So if any one of these is fine, this is perfectly acceptable if you want to leave it that way. This bottom one is probably what you would have ended up with if you had done the the quotient, or sorry, the product rule and the chain rule. All right, so there you go. That's taking derivatives of exponentials. I'll do one more video about this, just an application problem. So have fun.